Hi everyone. Today we're going to talk about algebraic expressions, and we're going to go through some examples of evaluating those algebraic expressions, and then I'm going to move into talking about sets and how to find the intersection and the union of those sets. P1 and algebraic expressions. So we know in algebra, they like to use letters, for example, x's and y's, in order to represent numbers, and then we call those numbers variables. So to start with, we're going to talk about orders of operation. And so we usually go along with that PEMDAS, that please excuse my dear algebra students, or Aunt Sally some people used, where the P stands for parentheses, E stands for your exponents, M is multiplication or multiply, D is divide. And multiplying and dividing, they kind of go hand in hand. So you don't always multiply before you divide. They're interchangeable. And on these ones, you read them like a book. So you read from left to right. So like a book, right? How do we read a sentence? We read it left to right. So the same thing when it comes to multiplying and dividing. So whichever one comes first is the operation that we do. A is for adding and S is for subtracting. And the same thing applies to these, right? We read these two, you read from left to right. So for just a quick little example, if we had, let's say 10 minus 5 plus 2. If we just read PEMDAS the way that it is, some people think that you have to add before you subtract, right? Or you don't. When it comes to adding and subtracting, they kind of work together. So we're just going to read this one from left to right. So the first thing we're going to do is 10 minus 5, which is 5, and then add the 2 and end up getting 7 as our final answer. So let's look at evaluating expressions. So if we're evaluating expressions, they're going to give us some variable that we're going to look at. So let's say they give us the expression 7 plus 5, then in parentheses, x minus 4 to the third. So we know this is an expression because there is no equal sign in the actual problem. So this is an algebraic expression. And they want us to evaluate. So evaluating is saying that there's going to be some value that you know that you're going to plug in. So they'll say that we're going to look at this expression for, let's say, x equals 6. So we know that x equals 6. So this is just going to go in for our x, or any x that's in the expression. We just have the 1. So we're just going to go ahead and plug that in. So we get 7 plus 5, then in parentheses, 6 minus 4 to the third. So now that we have all numbers, then we can just go through and evaluate by using our orders of operation. So first thing we're going to do is parentheses. So 7 plus 5 times 2 raised to the third power. Exponents, that third, or that 3, is being raised to the third power, so that's our exponent. So we'd have 7 plus 5 times 8. And then we're going to multiply, right? 7 plus 40. Then we're going to add those together and get 47 for our final answer. So these take practice, is all that it takes. Once you guys know the orders of operation, it's just a matter of putting in some practice and some pencil on paper to kind of get back into the habit of making sure that we're following the right orders of operation. So we're going to talk about this thing called sets. So in math, we like to create sets, and all a set is It's just a defined collection of objects. So a defined collection of objects. And then we have these things called elements. And the elements are just what those objects are. They are the objects in the set. So, for example, when it comes to making a set, the way that we know that it is a defined collection, and we need that word collection. So we're putting things together. So we know that it's a collection, or we know that it's a set. We use the little brackets that I'm awful at writing. I apologize. And then I'm going to put in 1, 2, 3, 4, and I'm going to say that that continues. That's what those dots would mean. And then I'm going to close that set with another bracket. So this whole entire piece, this would be my set. And then I have elements inside that set, these objects. So 1, 2, 3, 4, and whatever other numbers are included, those are my elements in my set. So there's two ways that we look at sets. We have intersections and we have unions. So let's start off with intersections. So the intersection of sets. So when we're talking about intersections, we use this little, we denote it by, it's almost like an upside down U, is how I kind of refer to it as. If we want to look at it as like a Venn diagram, you would have a set of objects in A, so set A, and you would have another set that would be B. So the intersection would be what they share in common. So the numbers or whatever the elements are that they both have, that would be your intersection. So it's almost like if you think of a road, beep, beep, right? Boop, 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 right? So we're driving down the road, and one of these roads, this is Vienna and this is Mill Street, right? Or whatever. So if I'm talking about the intersection, I'm actually talking about that spot that's right there in the middle. And that intersection is shared by both roads. So the intersection is the shared information. So we're going to write this as, let's say, A, the intersection of set B. What does that equal? We're going to make our little bracket because we know that it's a set of information. And we're just going to make up a variable, and I'm just going to use X. And then I'm going to draw this little line. And that's telling me that X is what I'm talking about, and then I'm going to define it. So I'm going to say that X is an element of A. And since we're talking about intersections, and an element of B. So it's got to be in both sets in order for it to be an intersection. So let's say we have the set 7, 8, 9, 10, and 11. And we know it's a set because it's got those pretty little brackets on there. And we want to find the intersection with another set of information. So a set of, let's say, 6, 8, 10, and 12. And we know that's a set because it also has brackets on there. So I'm going to look at the elements of both of these, and for it to be the intersection, it's going to be what it shares in common. So I can see that I have an 8 in common, and I have the 10 in common. So my intersection of these two sets is going to give me another set, so we have to make sure we have it in our little brackets. See if I can draw that a little better for you. Probably not. Sometimes they work. So what do they have in common? Element 8 and element 10. And I'm going to close that with the bracket. So that's how I know that it's the intersection. So this would be my final answer. So let's try one more. Let's say we have the set 2, 4, 6. and we want to find the intersection of that set with the elements 3, 5, and 7 in this set. Okay? So when I'm looking for intersection, I'm looking for that where they're in both. I got 2, 4, 6, 3, 5, 7. So they don't have anything in common. So when they don't have anything in common, we call it the empty set. And to draw the empty set, you're going to draw like a 0, but you got to draw that line through it. Right? And this is either referred to as the empty set or the null set. We just want to make sure that when we're doing this, we're not just saying like that there isn't any or a 0, because a 0 is a number and it could be an element of the set. So we need to make sure that that line goes through it that tells us that it's the empty set. So I think we're good on intersections. So let's talk about the union of sets. So instead of the upside down U, it's going to be like a right side up U. If we think of those Venn diagrams, we got set A and we have set B. So the union is everything. It's in one or the other. So that means it's going to be in A or it's going to be in B. So if we had A union B, let's try that again. A union B. And what does that equal? Well, we're going to make our little set notation. And just for the fun of it, I'm just going to stick with X as my variable. So by definition, X is an element of A or an element of B. So let's say we have, let's just stick with 7, 8, 9, 10, and 11. Being creative today. And I want to find the union of that set with the set 6, 8, 10, and 12. So in order for it to be the union, it's going to be in one or the other. So I know that I'm going to get a set of information or a set of elements. So I got 6. I have a 7. I got 8 in both of them, so I just need to write it once. I have a 9. I got 10 in both of them. I only have to write it once. 11 and also 12. And that fills my set. So for it to be a union, it's going to be in all of them, one or the other. All right. So I think it's time for you guys to give me a little bit of practice on. So if you have any questions, you can come on tomorrow into the beginning of the class or the beginning of the hour into Zoom. And if you have any questions, we can talk about those. Thanks for watching. Have a good day. Bye.